Okay everyone, we're almost done. We're up to 5.6, which is on clearing fractions. We'll do this over 2 days. We'll do some super tough ones next day and some just merely very tough ones today. They're hard, okay? Even today's stuff's really hard. So we're going to clear fractions. 5.6, clearing fractions. What does that mean, clearing fractions? Well, it's also called clearing denominators. And basically, it's a method of eliminating all the fractions in an equation. I think you'll agree with me that something that makes equations like these ones at the bottom here, look at these equations down here, what makes these look so hard is the fact that they have fractions in them. So wouldn't it be nice if you could get rid of the fractions, get rid of the denominators? Yeah, that would be good, and that's what we're going to do here. So I'm going to tell you how to do that in a second, but first I'm going to see if you can kind of figure it out here. So I have this question. Eliminate the denominators in the following fractions by multiplying. So this fraction right here, the 3 over 4. What could you multiply this fraction by? So I want to multiply this fraction by something. And then the answer will not have a fraction in it. You know what you can multiply by? There's actually tons of answers. One answer that would work is 4. Now, why would that work? A lot of people, when they see this, they say, no, that wouldn't work because you'd have 3 times 4 is 12 and 4 times 4 is 16. You still have a fraction. That's not correct. That's not how you multiply. When you have a whole number like 4, what do you do when you multiply in a fraction? You turn that number 4 into a fraction. So you make it 4 over 1, right? Any whole number can go over 1. And now you go ahead and multiply. But wait a minute. Remember what you can do when you multiply? You can ninja slice. And if you divide this by 4 and this by 4, you end up with 1 and 1. And so when you multiply, you get 3 times 1 is 3, and 1 times 1 is 1. But wait a minute. 3 over 1 is just the same as 3. We did it. By multiplying by 4, we got rid of the denominator. So just to clear this up a little bit, I want to be clear that what we did is we multiplied by 4, that canceled out the 4 and the 4, and you were left with 3. Now that's not the only number that would work. Can you think of another number that I could multiply this by, and you would get rid of the denominator? How about 8? If you multiplied by 8 and then ninja sliced, you'd have 1, 4 by 4 is 1, and 2, 8 divided by 4 is 2. Then when you multiply, you'd go 3 times 2 is 6. Okay? So far we know that 4 would work, 8 would work. Can you think of one more number that would work? There's an infinite number that would work. How about 12? 12 would work. If you ninja slice the 12 and the 4, divide them both by 4, this becomes 1, this becomes 3. 3 times 3 is 9. That'll work as well. So 12 worked. Hey, what do you notice? The numbers that will work are any multiple of 4, right? Since the denominator is 4, you could multiply by 4, 8, 12, 16, 20, 24, anything. 400, 4,000, whatever you want, as long as it's a multiple of 4. But let's just go back to the most basic one, which is multiplying by 4. Then these canceled out and became 1 and 1, and 3 times 1 was 3. Alright, how about if it was 2/3? You wouldn't multiply by 4 this time, obviously. You'd multiply by 3. So, you put 3 there, you cancel out the 3 and 3, divide them both by 3, and you get 1 and 1. And then you multiply across the top, 2 times 1 is 2. On the bottom, you just have 1, but you don't need to put it. Okay, that was what 3 would work here. What other numbers would work? Well, 3 would work, 6 would work, 9 would work, 12 would work, all the multiples of 3 would work. Which takes us to this question. What if I asked you both of the ones we just looked for, 3/4 and 2/3, and I want a number that will get rid of both denominators? Okay, in this case, what did we multiply by here? We multiplied by 4. That won't work for both of them. It would get rid of this denominator, but it would not get rid of that denominator. In the other one, we multiplied by 3. That would get rid of this denominator, but it wouldn't get rid of that denominator. So can you think of a number we could multiply both of them by, and it would work? Well, how about the common denominator of these, preferably the lowest common denominator? What's the lowest common denominator of 4 and 3? 12. If you multiply by 12, so it's a bit awkward, let's see, I'll write 3/4 again. And if I multiply by 12, what happens? You're going to divide the 4 and the 12 by 4. That gives you 1 here and 3 here. And then when you multiply, you get 3 times 3 is 9. So it got rid of that denominator. Let's see if it works for the 2/3. If we go 2/3 times 12, Again, we can ninja slice the 3 and the 12. Divide them both by 3, you get 1 and 4. And when you multiply 2 times 4, you get 8. So it worked. Your strategy is going to be to multiply by the lowest common denominator. Now, it doesn't have to be the lowest. I could also multiply it by 24, 36, 48, but it's going to make your life a lot easier if you pick the lowest common denominator. So, here is the important part right here. Your strategy for clearing fractions is to multiply every term by the lowest common denominator. And I better underline a couple times here. Every term by the lowest common denominator. You'll see why I'm making such a big deal of that in just a second. Alright, this is getting very obnoxious, but I'm going to do it one more time. Actually, I'll probably do it again tomorrow, next video. But here's all the steps. You now know them all. Number 1, eliminate any fractions by multiplying every term by the lowest common multiple, also called the lowest common denominator. Is that going to help if I also put LCD here? Whichever one makes more sense to you. It's the same thing. So this is our new step today. I'll highlight it there for us. These ones you've seen before. Get rid of any brackets using the distributive property. Combine like terms on the same side of the equal sign. Move all the variables to one side of the equal sign. Remember, try to add or subtract the smaller amount if you can. Isolate the variable and then check your answer if that's something you want to do. You should do these steps in this order. Okay, don't decide, hey, I'm going to start moving the variables to one side right away. No, do them in this order. So the first thing you want to do is get rid of fractions. Alright, let's try this here. So this question looks hard because we have denominators. We have a denominator here, we have a denominator here, we have a denominator here. So you got to figure out what is the LCD, or the LCM, the lowest common denominator of 5, 3, and 15. Well, they all go into 15. So what your strategy is going to be is you're going to multiply all of these things, all 3 of these things, by 15, every single one of them. And now you'll know this works if once you do this simplifying stage, the ninja slicing, you have no more denominators, or you just have 1 in the denominator. If you have any other number in the denominator besides 1, you did something wrong. Okay, you should have no fractions after this step. So let's try it out. On this one, I have a 5 and a 15, and I'm going to ninja slice. So I end up with 1 down here, because I'm dividing by 5, and 3 up here, because I divided by 5. On this one, the middle one here, I'm going to divide them both by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. And in this one, I'm going to divide them both by 15. 15 divided by 15 is 1, and 15 divided by 15 is 1. Great, it worked. I have all 1s on the bottom, which means I don't even need to worry about those anymore. Okay, so let's look back at the question. What I now have is 3 times, remember this was multiplying, 3 times 4x. Well, 3 times 4x is 12x. Then I see a takeaway sign. Then I have 5 times 2, which is 10, equals 1 times 2, which is 2. And now you get to go way down your list of steps. You're already down at isolating the variable. So try to add or subtract first. This minus 10, I can add 10 to both sides. So I get 12x, this is gone, equals 2 plus 10 is 12. This is 12 times x, so I do the opposite. I divide by 12. And that leaves me with x equals 12 divided by 12 is 1. And we're done. Okay, next question. We have some denominators here, 6 and 2. And we want to find the lowest common denominator of 6 and 2. Well, the lowest common denominator is 6. So we're going to multiply every term by 6. Now, be careful. When I say every term, I mean every term. So what most people do is they say, I'm going to multiply this by 6, and I'm going to multiply this by 6. But there's a third term here, this negative 5 or this takeaway 5. You have to multiply that by 6 as well. 6. If you don't also multiply that by 6, you're going to get the question wrong. You've just unbalanced the equation. Okay, let's do our ninja slicing. 6 and 6. I can divide them both by 6 and I get 1 and 1. 6 and 2. I can divide them both by 2 and I get 1 and 3. And here, there is no denominator. Or if you want, there is a denominator. It's already 1. And that's what we're trying to get is 1 on the bottom. Because once you have 1 on the bottom, you're good. You don't have to worry about the denominator anymore. Okay, let's multiply. Here we have 1 times x, and that's it. 1 times x is just, well, that's just x, isn't it? Then I have equals 3 times 1x is 3x. And then I have this takeaway sign. 6 times 5 is 30. Okay, good. With no brackets, do we have like terms on the same side? No, you can't combine those, 3x and 30. So we're going to go to the next step, which is getting all the variables on one side. You want to either move all your x's to the left or all the x's to the right. So it's up to you. I know we usually move the smaller one, so you might be thinking, okay, I'm going to move this x, this minus x. But remember, if you do that, you're going to end up with a 0 on this side. That's fine. It'll work. You're just going to do a little bit of extra work, but it will still work. This is one case where I'm going to move the bigger one, so I end up with still stuff on both sides. So I'm going to subtract 3x and subtract 3x. Now remember, this is 1x. So I have 1x, take away 3x. That's negative 2x. And on the other side, this is gone, but I still have negative 30. Okay, this was negative 2 times x. I do the opposite. I divide by negative 2. Do the same over here. So the negative 2's cancel. I have x. And negative divided by negative is positive, and 30 divided by 2 is 15. And we're done. Okay, getting nice and hard now. Lowest common denominator is, if you want to think of these whole numbers with denominators, they have ones, right? You can also do this if you want, if that helps you remember. So you're looking for the common denominator of 1, 3, 1, 2, and 1. We'll ignore the ones, and we're basically looking for 3 and 2. I think we already did that. It's 6. So you have to multiply every term, 1, 2, 3, 4, 5 terms by 6. And now we can ninja slice. 6 and 1 is already good. There's nothing you can do there. 6 and 3, divide them both by 3. You get 1, and 6 divided by 3 is 2. This has 1 on the bottom. We're good there. This one has 2 on the bottom, so we're going to divide them both by 2. You get 1 and 3. And now we can multiply. I have 6 times 6, which is 36. I have 2 times 2x, which is 4x. And I have 6 times 2, which is 12. On this side, I have 3 times 5x, which is 15x, and 6 times 3 is 18. Sorry, I forgot the minus there. 6 times 3 is 18. Okay, there's no brackets to worry about. Do we have like terms? Yes, on this left-hand side, we do have some like terms, don't we? We have a 36 and a plus 12, which gives us 48, plus we have the 4x, equals 15x minus 18. Let's get all our x's to one side. Let's move the smaller one this time, the 4x. So minus 4x and minus 4x. So 48 equals 15x take away 4x is 11x and minus 18. Got to get this x by itself. Let's look for an adding and subtracting step first. So I will add 18 and add 18. 48 plus 18, 8 plus 8 is 16, carry the 1. 1 plus 4 plus 1 is 66 equals 11x. Last step, divide by 11. Oh, isn't that nice? It goes in equally or evenly. It won't always, of course, but in this case it does. We get x equals 6. Nice. Moving on. Whoa, look at this. You have x's in the denominator. Any idea what the lowest common denominator would be if the only denominator you see is x? Well, then the lowest common denominator is x. That's right. And you're actually going to multiply every term by that x. So x, I should have made a different letter, it looks like times. But x, x, and x. Okay, I know this is confusing, but if you have an x on the top and an x on the bottom, you can divide them both by x. X divided by x is 1, x divided by x is 1. Same here. X on the top, x on the bottom, divide them both by x. X divided by x is 1, x divided by x is 1. Nothing you could do over here. Okay, we're ready to multiply. You have 1 times 4, which is 4, minus 1 times 3, which is 3, equals 10 times x is 10x. Combine like terms? Absolutely. On this side, 4 minus 3 is 1, equals 10x. And then your last step. This is 10 times x. We do the opposite and divide by 10. 1 divided by 10 does not equal 10, people. I know you'd like it to, but that's what 10 divided by 1 equals. 1 divided by 10 is 1 over 10. Or, if you want to put it in your calculator and get a decimal, 0.1. Either of those answers is great. And now we get to these incredible questions. So, our denominators in this case, we have a 4 and we have a 2 all the way over here. So our lowest common denominator is 4. We're going to multiply this by 4, this by 4, this by 4, and this by 4. 4 fours. In the first one, you can divide them both by 4, and you get 1 and 1. In the second one, there's no denominator, you're good. Third one, no denominator, you're good. And the last one, you got a 4 and the 2, divide them both by 2, and you'll get 1 on the bottom and 2 here. We're ready to multiply. 1 times 1x is 1x. 4 times x is 4x. Equals 4 times negative 3 is negative 12, and 2 times 1x is 2x. Okay, let's combine like terms. On the left hand side, 1x plus 4x is 5x. There's nothing you can combine on this side. Next, let's get all our x's to one side. 5x and 2x. I'm going to move the smaller one, the 2x. So minus 2x and minus 2x. So we have 3x equals negative 12. Last step, divide by 3, divide by 3. X equals negative 4. Okay, last one, lowest common denominator. I see denominators of 3, 2, and 4. Ooh, what do 3, 2, and 4 all go into? They all go into 12. So that's what I'm going to be multiplying. 12, 12, 12, 12, 12, 12. Oh my gosh. So let's see. We have a 12 and a 3. Divide them both by 3. You get 1 and 4. There's no denominator here. You're good. 12 and 2. Divide them both by 2. You get 1 and 6. No denominator here. 12 and 4. Divide them both by 4. You get 1 and 3. And no denominator here. We're ready to multiply. So I have 4 times negative 2w. Don't forget about that negative. 4 times negative 2w is negative 8w. 12 times 1 is 12. 6 times negative w, that's the same as negative 1w, right? So 6 times negative 1 is negative 6, and then there's a w, equals 12 times negative, or if you want negative 1w, is negative 12w. 3 times negative 3, so many negatives here. 3 times negative 3 is negative 9, and 12 times negative 3 is negative 36. Definitely have some like terms. On the left-hand side, we have a negative 8w and a minus 6w. So you might need to add the opposite. Negative 8 minus 6 is the same as negative 8 plus negative 6. Two negatives, when you add, it's still negative. It's a bigger negative. And 8 plus 6 is 14. So negative 14w plus your 12 here equals. On the other side, you have negative 12w, and you also have these two like terms. Negative 9 take away 36. So again, if you want to add the opposite, it's negative 9 minus 36, or negative 9 plus negative 36. Again, both negatives, so your answer is going to be negative. 9 plus 6 is 45. Alright, we have w's on both sides. Let's move the smaller one. What's smaller, negative 14 or negative 12? Negative 14. So I add 14w and add 14w. So we're left with 12 on this side. Negative 12 plus 14 is 2w minus 45. Got to get this w by itself. Better add 45 on both sides. So we have 57 equals 2w. And finally, we're going to divide by 2. Here's a question I really would not want to check, because I would not want to plug 57 over 2 into all those w's up there. So 57 over 2 equals w. I'm actually just going to write the w up front, because I'm also going to switch this into a mixed fraction. That would be 28 and 1/2 left over, or as a decimal, 28.5. Okay, your answers can certainly be fractions and decimals when you do these. They often will, actually. Alright everyone, you now know all the rules. There's just one final step to take, still involving clearing fractions, but you might have noticed that we did no distributive property in this lesson. So next time we'll do the clearing fractions, but bring back distributive property. Alright, see you then. Take care.